in structure file design and the implementation of the structure file design in AxisVM software. The main points will be today a short introduction, few slides about structure file design itself, and few words. Second time, implementation in the software, and finally, some live demo and practical consideration, how to consider and how to apply file loads in the software and how to perform structure file design in AxisVM. About structure file design and file design of buildings. File design of buildings is a very important issue of building safety. It is very important. The consequences of a possible fire are severe, and the nature of fire is highly nonlinear, and structure response also very highly nonlinear given to a possible fire. So we have to ensure the reliability of the structure elements against a possible fire, a possible failure in a fire. Requirements regarding insulation, integrity, and load-resisting capacity may be found in national fire safety regulations. According to structure file design and structure reliability, we can find reliability criteria, definition of fire actions, combination rules, design methods, and others in, for example, in Eurocode standards, and in more detailed form, reliability and combination rules in Eurocode 0, definition of fire action and fire roles in Eurocode 1, and material-specific rules may be found in Eurocode 2, Eurocode 3, and Eurocode 5. A very important question is the representation of fire effect in the calculations. The mostly used representation of fire effects in design is the use of fire curves. Fire curves are basically functions. They give the gas temperature in the compartment as a function of time. Here you can see some example fire curves in this figure. The use of fire curves is a typically conservative solution because, for example, they assume the same temperature everywhere in the compartment. The mostly used fire curves are ISO standard fire curve, external fire curve, hydrocarbon fire curve, parametric fire curve. We can apply custom fire curves based on more sophisticated simulation results, and there are other type of fire curves, for example, national specific ones. I listed one from the Netherlands. The most important fire curve is the ISO fire curve. It is the we use mostly ISO standard fire curve. It is more like a comparable effect than an actual fire. ISO standard fire curve neglects the decay phase of the fire, so it increases with the time, and there is no decay phase, and we do not consider the start phase of the fire. We start the calculation from the flashover. So the most important fire curve is more like a comparable effect than actual fire. Further options are modeling of a fire are localized fire models from the standard, advanced fire models like 1 zone, 2 zones, or multiple zone models, and of course the most sophisticated one, the CFD, computational fluid dynamic simulations and models. Few words about the fire design in AxisVM. It is important to know that fire design in AxisVM is based on prescriptive rules according to the standards and design codes, using fire curves, and simple calculation models. It is also important that we developed our modules using member analysis. It is an approximation giving the opportunity to analyze only one member from the structure at a time. So we consider an isolated member and we perform our calculation on that specific member, and we continue with another one. We have several modules, existing modules related to structural file design in AxisVM. For example, SD8 for structural file design of steel elements from X4, version X4. We have TD8 for structural file design of timber elements from X5. And I am glad that I can announce our new RC8B module for structural file design of reinforced concrete columns and beams from X6 release 2. And it is very important that we have an upcoming new module in X7 dealing with the structural file design of reinforced concrete surface elements like slabs and walls and shells. It will be called as RC8S. I think that these modules at this moment as well and in the future from X7 will give a complete package for everyone for the majority of design problems. Few more words about implementation. In order to perform structural file design in the software, we have to add fire load groups and fire load cases to the model in this familiar window. Different fire scenarios can be modeled using fire load groups. For example, we can model a fire in compartment 1 or in compartment 2, or we can, using a simple checkbox, we can decide to consider a fire in compartment 1 and in compartment 2 at the same time. It gives a very big freedom, a large freedom to our users to model different scenarios. It is also important to know that we can perform structural file design only load combinations contain at least one file load case. But it is logical, of course. About the definition of file loads, we have to select file load case on loads tab, and after that we will see this button active here in the tab, and since we can apply only file load parameters to elements in this case, this button will be active only and no other buttons. And depending on the features or package you have, you can select timber, steel, and or concrete elements, depending you have SD8, TD8, or RC8 modules. Okay, continuing with steel elements. Structural fire design of steel elements can be performed according to Eurocode 3 and SIA design codes. As I told earlier, we can perform a member analysis where we need to know for an isolated element the internal forces, the boundary conditions, material cross-section, and very importantly, the steel temperature. I would like to give you tell a few words about why we need to know steel temperature, how can we calculate steel temperature, and how to use the steel temperature. The steel temperature is very important because the steel material is a good heat conductor, and the steel temperature, the temperature of the element increases rapidly in a fire. And another problem is that the strength and stiffness parameters of the material decreases rapidly. Here you can see a figure from Eurocode standard where some functions are shown. For example, the yield strength reduction factor as a function of temperature, and the reduction factor for stiffness of the material as a function of the temperature. You can see that they decrease rapidly at elevated temperature. That causes that steel structures are typically very sensitive for strength and stability failures in a fire. How we can calculate the steel temperature? It is very easy because Eurocode 3 gives us closed formulae to obtain the steel temperature. For example, here I listed the first one for unprotected steel members and the second one for protected elements. As you can see, if we have a few parameters, we can obtain the steel temperature shown as a black curve here in this figure from AxisVM documentation. And how to use these reduction factors and consider the temperature in the calculation? The answer is that the consideration of the reduction in strength is very easy. We apply this reduction factor for the yield strength, but if we have to consider some instability problem, we have to calculate new buckling reduction factor for flexural buckling, lateral torsional buckling, and others, and web buckling, everything. So we have to calculate new buckling reduction factors and new strength. And after that, we can obtain, for example, the buckling resistance of a simple column. Okay, continue with steel. This is the window where we can define the pilot parameters for steel elements. First of all, we can decide which fire curve we would like to use. And we have to give the requirement in minutes for resistance. This value is coming from national regulations, fire safety regulations that tell us how much time our building needs to resist in a fire. So our regulation will give us 30, 60, 90, or whatever requirement in time for load-bearing capacity of a possible element. We can define the fire protection and the exposition, of the member. It is very important, coming back to the requirement, that basically 30 minutes or more for steel elements cannot be resisted without fire protection. It is very important. The majority of support questions and emails are coming from this issue that in steel design we have very high utilizations due to the fact that we have 30 or 60 minutes requirement, and our user did not use any fire protection, and we have 800, 900, and 1000 degrees Celsius steel temperature that can resist nothing, literally. Another important issue need to be noted is this button here, temperature distribution analysis. This is an extra option developed for special cases and developed this kappa 1 parameter that is beyond the scope of this presentation. But what I would like to tell that this part of the window is not needed. This black curve represents the steel temperature according to Eurocode standard, so calculated automatically. So we do not need to run this temperature analysis. The structural file design of steel elements can be performed in AxisVM like conventional design. We select the element, we set the parameters, and we set the load combination, and AxisVM gives us the results. The important in case of steel file design is to go to design parameters window and enable file design of the element. This can be done by clicking this button here in the window, which opens us this part of this window. Oh, sorry, this part of the window where we can set different backlink parameters for every element. It is also very important. Typically, steel buildings very often covered with thin-walled sheets and purlins that loses their supporting load-bearing capacity and stiffness very quickly in a fire, which requires us to consider different backlink parameters in fire than in normal temperature design. For example, in normal temperature design, I may decide to consider the purlins and sheeting by supporting my member and help to avoid instability problems. But I decide to neglect this effect in case of fire. After performing fire design, I can see the results in model window, in design calculation documentation, and in very useful summarizing table called utilization in fire. I put this picture here because a very important, I would like to show you something very important, this column here. This is the so-called critical temperature. This temperature is associated with the failure of the member. So, for example, if I select the member, this temperature will give me the temperature where the member will fail. This value is needed to calculate the required intumescent painting material, the thickness of intumescent painting, which used very often as fire protection of steel elements. Another important value to calculate intumescent painting is the section factor that is available in load tables, in fire load tables. According to structural fire design of timber elements in AxisVM, the structural fire design of timber elements can be performed according to Eurocode 5, Part 1, Chapter 2, and CR 265. In this case, we perform member analysis as well. We need to know internal forces, boundary conditions, material cross-section, and charring depth. Charring depth, we know, of course, that timber chars in a fire. That makes us that requires us to use a reduced cross-section method, where we do not consider the whole cross-section. We consider a smaller cross-section than the original one, and according to Eurocode, we can formulate our equations and calculate the stresses comparing to strength, where I show you an example here for this how you can perform. This is the basic of timber file design of timber elements, the reduced cross-section method. By the definition of fire loads on timber elements, you can see this window where, similarly to steel elements, we can choose fire curve. We can give the requirement in minutes. We can select exposition of the member, 4-sided, 3-sided, 2-sided, and more options, and the software automatically calculates the charring depth. Structure by design of timber elements can be performed similarly to steel elements. We need to open the right side of the window with this button, where we can define different batting parameters. The results of, and it is important that the flow chart, the steps of the work need to be done are the same we do in normal temperature design. Only we to do is to open the window with this button, select the specific load combination or critical or envelope load combinations containing fire load cases. The results of the design are summarized in utilization fire, very useful. Summarizing tables can be attached to the model documentation. And here I show you design calculation documentation, where you can analyze and check the details, how we performed the structure file design. Few words about our new module developed for file design of reinforced concrete line elements, namely columns and beams. Structure file design of these kind of elements can be performed in AxisVM according to Eurocode 2 and CIA 262. As I told you earlier, we do member analysis. We need to know internal forces, boundary conditions, material cross-section, reinforcement, and temperature distribution within the cross-section. In this case, temperature distribution is very important because the concrete is not so good conductor of the temperature. So here we have very big differences based on the position in the cross-section in the temperature. So it is important to consider. We applied simplified calculation model called 500 degree of Celsius isotherm method, where we consider only concrete parts where the temperature is below 500 degrees, and we neglect the outer damaged concrete layer, and we consider the reinforcements, the rebars with stiffness and strength parameters according to their actual temperature. We consider different temperature for every rebar, so it is very economical and accurate calculation. We decided not to use tabulated data. It is very common, but it can be used only standard fire curve, ISO standard fire curve. It has major limitation, and due to these limitations, it is good only for the majority of elements in normal buildings. So we decided to apply, to go a step further and apply this simplified calculation model. During the definition of fire load parameters, we can select the fire curve, we can design the requirement, we can define the exposition, and in this case, we need to do a temperature distribution analysis within the cross-section. And after clicking this button, we can see this beautiful image where we can analyze the temperatures within the cross-section. we can perform this analysis for circular and not only for rectangular sections, and of course we can do it for beams as well. About some words about temperature distribution analysis. If we click on analysis button, we perform a two-dimensional heat transfer problem. We solve a two-dimensional heat transfer problem by finite difference method. The problem is discretized in space using 2 by 2 centimeter mesh, and time using 30 seconds time step. The boundary conditions applied are the exposed, non-exposed, and symmetric conditions in order to accelerate the calculation. And it is important that it is an independent analysis. The results are validated with isotherm profiles from Eurocode 2. Some words about reinforced concrete beams. The workaround is the same. What we need to do in case of fire design is the same what we do in normal temperature design. After we have the fire load parameters, we do the same. Select the beam, go reinforced concrete design tab, and start beam reinforcement design. Some words. Annex B of Eurocode 2 simplified method is used to formulate the equilibrium of the cross section, and shear and torsion checks are made as Annex D of Eurocode 2. It is important that we need to enable the fire resistance design using this checkbox here on beam reinforcement parameters window. I can tell you the same for reinforced concrete columns. There is no special steps. After we have final load on the element, we can select load combinations where final load is included for that specific element, and then the software will consider special rules of fire design. And in this case, we need to enable fire resistance design on these parameters, very familiar parameters window of the reinforced concrete column. Okay, this is my first example. I would like to show you first a steel frame, where first I would like to show you how to add fire load groups and fire load cases to the model. We can go to load tab and open this familiar window, load groups and load cases, and I can add new fire load group and fire load cases to the model very easily. And then after select the fire load case, I can define fire load parameters to my model. Here I need to select fire load case to define the fire load parameters of the member. After I selected the fire load case, I can go here and click the button and select a column, for example. And this window opens, as I showed you in the presentation. Here I can decide which fire curve I would like to use. I can use ISO fire curve, external fire curve, hydrocarbon fire curve, parametric fire curve, and I can use user-defined fire curve. At the moment, as a default, ISO fire curve is uploaded here, but you can give any kind of fire curve here. Okay, I go back to ISO fire curve. Here I can define my requirement in minutes. For example, I have 30 minutes. I give 30 minutes, or I have 90 minutes. I give 90 minutes. And as I as you see here, the software automatically calculates the steel temperature for the design. Here you can see the reduction factors for stiffness and strength parameters of the material at the calculated steel temperature. We can apply the fire protection and we can select whether it is covered that follows the perimeter of the element, or it is covered as a box with fire protection material. Of course, it influences the calculated steel temperature, and I can decide to not use any fire protection, which makes my steel much more higher much more. I will have much more much higher steel temperatures. Another important thing that I can apply this steel temperature as thermal load. So AxisVM will consider the restrained thermal elongation of the elements, but it is also important to know that I do not have to do that, only in special cases. Generally, in case of member analysis, according to Eurocode, I do not have to apply this temperature as thermal load, only in special cases. Okay, I have to run static analysis. I did it earlier, and go further to steel design tab. I can define the design parameters for the same elements. I need to open the right side of the window. It shows us that fire design, structural fire design is enabled for that element. Okay. I receive a warning that tells me design checks are incomplete, which means that not every possible design check were considered. I see this window, and it is important also. I see this window because this checkbox here is checked. The reason of this checkbox and the message is that Eurocode 3, Part 1, Chapter 2 does not cover all possible failure modes of a column. It has information only, not few, but not the full package of possible failures of an element. So if I would like to strictly follow the fire part of Eurocode 3, I may not consider every possible failure mode. So if you check it, you will consider failure modes only listed in Eurocode 3, Part 1, Chapter 2. If you uncheck it, you will have information about failure modes that are not covered by Eurocode 3, Part 1, Chapter 2. And we can check the utilization for a load combination, including fire loads. And I can show you a very interesting drawing. The critical steel temperature, as I told you earlier, it is very important parameter of the selection of intumescent coating. And I show you design calculations. It will give you all the details what we have done. And you can access very easily to utilization in fire table. If we are on steel design tab, if we have fire design completed, we click this button, and this very informative and summarizing table opens, where I have an extra column for critical temperature. Okay, and I would like to show you another example. I will not cover everything what I did in the previous example. I would like to show you only what we did for reinforced concrete elements. Here you can see a reinforced concrete building where I defined some parameters to different cross sections. For example, here I have a rectangular column section. Here I can also decide between different fire curves. I can choose the requirement, the exposition, and I can run an analysis, a temperature distribution analysis. If I have a beam and not a column, it is not a problem. Here I can see the temperature distribution in my beam. And if I click doubly, I will see a more detailed window, a bigger window with this drawing where I can check the temperature in the element. And the possibilities are cover the circular cross sections as well. And I have fire load case, conventional fire load cases. I have load combinations. After I completed the static analysis, I can go further in reinforced concrete design and selecting my element, I can perform the structure by design, which does not require extra steps, only enable the design, the structure by design, and then special considerations, special rules and requirements will be considered in the course of the design, and I can check the details and results of my calculations.